A mesmerizing celestial event is currently unfolding above us, and it's captivating not only professional astronomers, but also backyard stargazers from every continent. At the center of this stellar spectacle is the colossal red supergiant, Betelgeuse, an ancient fiery titan that marks the shoulder of Orion, one of the most recognizable constellations in the night sky. For decades, Betelgeuse has been a familiar winter companion to skywatchers in the northern hemisphere, glowing with a steady, ruddy light. But as of May 2025, something extraordinary is happening. Betelgeuse has grown significantly brighter, its luminosity surging by an astonishing 50%. This dramatic uptick has pushed the star from its former ranking as the 10th brightest in the night sky to an impressive 7th place. This brilliant glow-up isn't just a random fluctuation. It's a powerful signal, a sign that monumental changes are occurring deep within the star. Betelgeuse, already known for its variable brightness, is undergoing a new chapter in its stellar evolution. What we're witnessing may well be the final acts in the life of this massive celestial body, a star that has burned for millions of years and is now marching toward its inevitable, explosive end. To grasp the enormity of Betelgeuse's size and impact, imagine placing it at the center of our solar system. Its outer layers would stretch past the orbit of Jupiter, engulfing Mercury, Venus, Earth, and Mars in its vast, searing atmosphere. It's not just big, it's colossal, the kind of scale that's difficult to wrap your mind around. Eventually, Betelgeuse will die in a cataclysmic supernova, collapsing under its own immense gravity. When that happens, it may leave behind a neutron star, or if the mass is great enough, a black hole. But that event, while inevitable, isn't expected to happen anytime soon, at least in human terms. We're talking on cosmic timescales, tens of thousands to even hundreds of thousands of years. Thankfully, Betelgeuse is located about 650 light-years away, close enough to observe in spectacular detail, yet far enough that its future explosion will pose no threat to Earth. When it finally does explode, though, the sight will be like nothing humanity has ever seen. Before the light of the explosion reaches us, Earth will be bathed in a silent storm of neutrinos, tiny, nearly massless particles that will escape from the collapsing core and reach us before any visible signs of the supernova appear. Sensitive detectors around the globe will pick up this wave of neutrinos, acting like an early warning system. Then, within hours or days, the star will brighten dramatically. In the space of just 1 week, Betelgeuse could become as luminous as a full moon. It might even be visible in the daytime sky, casting eerie shadows at night. The glow could last for weeks or even months, offering an unprecedented opportunity to observe a supernova in real time with modern instruments. But to fully appreciate this current chapter, we need to rewind to late 2019. That year, something strange began to happen. Betelgeuse started to dim in a way no one expected. Its brightness dropped so significantly that even those unfamiliar with telescopes could spot the difference with the naked eye. The astronomy community was abuzz with speculation. Could this be the start of the long-anticipated supernova? Telescopes all over the world turned toward Orion. The European Southern Observatory's Very Large Telescope observed strange behavior in the star's outer layers, particularly the photosphere, the surface we can see. It was expanding. Then, suddenly it stopped, and the star looked cooler and darker. Between January and February of 2020, Betelgeuse reached the faintest level of brightness ever recorded. For a time, some experts seriously considered whether we might be witnessing the star's final days. Then, slowly, the star began to brighten again. Theories abounded until scientists finally pinpointed the cause: a surface mass ejection, SME, something similar to the solar flares our own sun releases, but on a scale almost too vast to comprehend. Betelgeuse had essentially coughed up a massive chunk of its outer shell, an eruption so powerful that it released material equivalent to several times the mass of the Moon. That debris formed a cloud of dust that temporarily blocked our view of the star, causing the observed dimming. Using the Hubble Space Telescope, astronomers were able to capture the first-ever images of such an event in a red supergiant. It was a landmark moment in stellar science, proof that massive stars can experience violent surface disruptions well before their final collapse. This event also had a profound effect on Betelgeuse's rhythm. As a semi-regular variable star, it typically pulses with a cycle of around 400 days. These pulsations are caused by internal processes, heating, cooling, expanding, and contracting as the star burns through its nuclear fuel. But after the SME, that pulsation period was cut in half. A star that once followed a cosmic heartbeat of more than a year was now throbbing every 200 days. It was as if something had shaken the star to its core. Astrophysicists now believe that a vast hot bubble of gas had risen from within Betelgeuse's convective interior, like a boiling cell of plasma the size of a planet. When that bubble broke through the surface, it disrupted the star's outer layers and triggered the mass ejection. This hotspot may also be the reason the star is currently glowing more brightly than before. As Betelgeuse continues to settle, scientists predict that its pulsation period will eventually return to the familiar 400-day rhythm, but this could take another 5 to 10 years. Meanwhile, researchers are watching closely, gathering data that could rewrite what we know about stellar life cycles and death. Despite the wild excitement, experts agree that Betelgeuse is not about to explode. Not yet. Its current stage of fusion is still producing carbon from helium. There are several fusion phases to go: oxygen, neon, silicon, and finally iron, before the core collapses. This means the supernova could still be tens of thousands of years away. Still, the fact that we are able to witness these dramatic changes in real time from a star located hundreds of light years away is a rare privilege. It's as if the universe has granted us a slow-motion preview of the grand finale. Beyond. The science Betelgeuse has long been embedded in human culture and storytelling. Its name is believed to come from the Arabic phrase meaning the armpit of the giant, referring to its position in Orion. Different cultures have seen different meanings in its glow. In Japanese folklore, it was thought to be a severed limb. In Brazil, it was a turtle's leg. In Hindu mythology, the moist one, linked to storms and divine rage. To the indigenous peoples of the Arctic, Betelgeuse's rising heralded the end of winter. These stories show that our fascination with the stars isn't new. It runs deep, across generations and geographies. Today, Betelgeuse continues to command awe, not just for its beauty, but for what it represents: the opportunity to witness, with our own eyes, the slow unraveling of a star's life. Unlike most stars, Betelgeuse is close enough and large enough for us to study its surface directly. It has become a kind of cosmic laboratory, a unique subject for testing theories of astrophysics that until recently were based on models and distant data, and its recent behavior has made it an even more tantalizing mystery. In fact, in a chilling and captivating comparison, astronomers recently observed a distant star in the Aquila constellation devouring one of its own planets. While Betelgeuse hasn't reached that level of cosmic drama, its turbulent changes hint at the raw, often violent processes that shape our universe. As we watch Betelgeuse pulse and flare, we're reminded that the universe is not a still picture, but a living, evolving story. And we're lucky enough to be here at just the right time, with just the right tools, to witness one of its most fascinating chapters. So next time you step outside on a clear night and look up at that reddish star in Orion's shoulder, take a moment to think about the incredible journey that light has taken from a stormy, unstable surface 650 years ago across the vacuum of space to your eyes. That light carries the story of a dying star, one whose legacy may help unlock the secrets of the cosmos. Isn't that something worth sharing?